In this lecture, we are going to learn about greedy algorithms, which is a tool that helps in solving optimization problem. So let's see what it is with one example. So we will look at a problem that is known as interval scheduling. So we are given a set of jobs, okay? So you are given a set of jobs where each job has got its start time and finish time, okay? For example, you have some classes and there is only one classroom where you have to take all those classes. So your start time of the class, end time of the class is given, and you have to schedule those jobs, okay, for which the start and end times are given, such that maximum possible number of jobs are scheduled. That is the problem. So let's try to see. So what are important things about job? If you have, let's say, jobs, our jobs are just classes, okay? You have just one classroom, so 2 or 3 multiple lectures cannot happen at the same time, okay? So the thing is, when some class is going on and this is the time span, this is S1 start and finish time, this is another S2 F2, and let's say we also have S3 F3, okay? So all these classes are actually, they are conflicting each other, okay? So they cannot happen in the same class. Why classroom? Because if we consider this class 1, lecture 1 and lecture 3, so they will be intersecting during this period, so this cannot happen. Lecture 2 and lecture 3 also intersect, and lecture 1 and lecture 2 also, they intersect during this time interval, okay? So even if they intersect for a small time interval also, so then we say that, okay, they cannot be scheduled together. So 2 jobs with overlapping intervals cannot both be scheduled. So let's try to see what is the criteria. So your overlapping can happen, okay, when this is the case, S1 F1, S2 F2, so they will overlap. So in this case, what is happening? If we consider this one as fixed, so S2 F2, so S2 should be less than your F1 and your F2 should be greater than F1, then they will intersect like this, okay? Other thing that can happen is this type of intersection, S3 F3. So here again this is intersecting and your S3 will be less than S1, but your F3 will be greater than S1, okay? So this will intersect, so this point should be coming somewhere, okay? So that's the condition. So that can be calculated between 2 jobs for which SI, FI are given. Then you can calculate in O1 time if they intersect. So this is there. So now let's try to see so how the algorithm looks like. So what it says is that initially R is the set of all the jobs request, okay, which have the initial time, start time and finish time, and we have the A is an empty set that will store all the jobs that will be scheduled. So while R is not empty, okay, so we are taking the request, so choose some job from R, okay, and add it to the set of the jobs that we want to be scheduled. And when I have scheduled something, okay, so let's say this is the job I'm scheduling, okay, J1, this is J2, this is J3, this is J4, then remove all R or request that overlap with I. So if I have selected J1, I will remove J2, J3 and J4 because they cannot now they cannot be scheduled because they are overlapping with J1. So if you choose some job, then remove all other jobs which overlap with it. So this is as simple. But the question is, how do you choose this such that this becomes optimal? That we have to schedule, okay? So we have to schedule jobs on one processor, and we have to maximize the number of jobs that I schedule. Of course, anyone, if there are classes going on, I would like that, okay, in that particular classroom is utilized maximum. So let's see some concrete example, okay? So here they have given one example. So these are your jobs, okay? So we have to schedule all these jobs on one machine or resource, and what we want is maximum number of jobs should be done by that particular machine, okay? Or maximum number of lectures should happen in the class. This is the timeline, okay? So this is your timeline. These are the classes, time span for the classes. So this is, let's say, class 1, S1, F1, this is S2, F2, and so on, okay? So now what happens is that we will schedule those jobs. So let's try to see. So we have these jobs. Now how to put them? So let's say first we think about earliest start time. So greedy algorithm says that when we are picking some jobs, let's pick the one which has the earliest start time, okay? So that we can pick those jobs which are starting the earliest. That looks quite good, greedy choice, that okay, whatever jobs are starting first, pick them. We are very greedy, but will it be the optimal choice? So let's try to see. What happens now is, which job is starting first, which has the minimum starting time. So this one has the minimum starting time. Now what you do, I have chosen this, okay, this one is fine for me, but whatever jobs are intersecting, now you cannot have them. So I find that, okay, going on the timeline, this will not be there, this job also would not be there, okay? Next I have to pick the second job. So whatever are available, in them we have this job is the has the earliest starting time, so I choose this one. So when you choose this job, then again I will find the intersecting ones. So this is intersecting, I will remove it. This is already removed, so not there. So now I have these two jobs. Which is the next job? So again now I have to search which job is the next available with earliest starting time. So this is the one. So we will choose this one, and then what you need to do, I have to remove this which is already removed. This one is intersecting, this one is intersecting, and let's say this one is not intersecting, okay? So now what we do, I have to schedule my next job. So this is the earliest starting time, I will pick this one up and then remove the others. So 4 jobs, 1, 2, 3 and 4 jobs I could schedule if these are the timelines that are given. So earliest start time, it looks good, isn't it? That okay, it's giving very good result, and even if you try others, it looks convincing, isn't it? So is it really? The thing is, when you are putting some greedy choice, first thing is, whenever you think about some algorithm or way to choose, think that will it always give me correct result, isn't it? So let's try to see one very simple example. I have some jobs, okay? So these jobs are here, these are the jobs on the timeline. and your time is 0 starts here, and I have some job, let's say this one, earliest timeline. This is the earliest timeline and this job. Now what happens? If I choose the earliest timeline, earliest starting time, then all these are now conflicting. So this one I have to remove. All these are conflicting, overlapping, so all these cannot be scheduled. So I will be only scheduling one job, okay? But, and this is basically by choice of earliest starting time. But if I have not chosen this, I would have schedule 1, 2, 3, 4 and 5 jobs, okay? But because of my criteria of earliest timeline, I just could perform only one job. So this tells that our choice of earliest start time is wrong, okay? It will not give us correct result, and hence it's not optimal. In this case it looked quite convincing, it might be giving us optimal result. So 4 jobs it could be done. Let's try to see here. So can we do better? So try to see in this example itself, okay? So let's try to see if we can do something better in our previous example. 1, 2, 3, 4 jobs we could do. Can we do something more? So 1, 2, if this is fine, they are not intersecting. 1, 2, then 3, then 4. This is one way of choosing. I think 4 is optimal in this case. 1, then 2 I can choose, then 3, then 4. So 4 looks optimal, but we could show you that okay, earliest start time will not always give you the correct result. So now what they do is they try out another choice, that is smallest processing time, okay? So let's try to see this smallest processing time. So process jobs in the order of processing time, okay? So we will process jobs that have the smallest processing time, starting with the job that requires shortest processing time. So these are the jobs. So this is the smallest processing time. I will do this one. This is bigger, this one bigger. So I can do 5 jobs. So it looks good, but this one we can find some examples where it will give us incorrect results. So let's try to see. So these are our 4 jobs, and this is our another job, okay, smaller job. So now if I start with smallest processing time, so which one should I do first? So I will go for it, but when I go for it I will remove the overlapping times. This will be there, then I can, if let's say this was a bigger one, I will schedule this, I will schedule this. So I will have 3 jobs, but you can easily see if I remove this one out, then 1, 2, 3, 4 jobs I could have done. So smallest processing time is also not correct. Next they are showing is that of process jobs in that have the fewest conflict. Now they are basically trying out various greedy methods. Now the newest one is fewest conflicts. So here this job has 1 conflict, this has also 1 conflict, this one has 2 conflicts, this has 1 conflict, this has 1 conflict, this one has got 2 conflicts. So I will start with the job that has fewest conflict. So this one choose, then this is removed. Now I have this one with no conflict, I will choose this. Fewest conflict, next one is this one. this is removed, so 4 jobs are done. This seems to be good, but here you have to be a person who always criticizes and finds faults. So finding fault in others is sometimes good, at least when you are trying out greedy methods. So whenever you think of some choice, so find fault in that. Can you create some case where your choice will give you wrong result? So let's try to see here what happens. Processing job with fewest conflict, they are showing the example, so 4 jobs could be done. Now processing jobs that have fewest conflict. Okay, so some noise is coming outside, so I have no control on that. So process jobs with fewest conflict, so here you have these jobs. So now what happens, I have which job has the fewest conflict. Now initially this has got 3 conflicts, this one also has got 3 conflicts, this has got 3, in fact 4 conflicts, this one has 2. So this is the job which has the fewest conflict. So I schedule this, then what happens, this is gone, this is gone. So now next one with fewest conflict is 1 2 3, this one has also 1 2 3. So I can schedule any one. So this is scheduled, all these are gone. Next fewest conflict is 3, all of them have 3 conflicts. I schedule this, all 3 are gone. So now you see I have 1 2 3 jobs I could do in this case, but you can see that I could have done this job, this job, this job, this job. 4 jobs I could have done easily if I had not chosen jobs with lowest conflict. So this is also wrong. So your greedy choices till now haven't worked. So let's try out another greedy choice. Next one comes with earliest finishing time. Okay, earliest finishing time, we had tried out earliest starting time. Okay, and one thing I want to tell you, we have tried something which looks intuitive. Okay, so whatever we have tried out, they are looking intuitive, so we are choosing them. But again, then you have to check some wrong result, because to prove correctness is very difficult, that okay it will work, give us the best optimal solution. But proving, even if you prove that okay in one case it's not working, then you are done. So process jobs in the order of their finishing time, beginning with the one that finishes earliest. Okay, so we will try out now job that finishes the earliest. So let's try to see here. So what happens, whichever is finishing earliest, I will choose that. So which one is finishing earliest? So this one, so I will choose this. Overlapping ones I will remove. Next one which finishes earlier is this one, I will schedule this. Overlapping I will remove. Then what happens, this was already removed, so next one which is earliest is this one, I will schedule this. And this is conflicting with this one, remove it. Next one that is finishing earliest is this one, have it, remove the overlapping. So 1 2 3 and 4 jobs are done. Can you find some problems here also? Process jobs in order of their finishing time. So can we create something? So finishing time is the earliest, so that means that okay there will be, this is the first one, there will be lot of other jobs who will be doing it. So this is the earliest the job is being done, so it guarantees that there will be lot of time left during which you can schedule. So this gives us in fact the best result. As you see, so this one is scheduled, and then we schedule this one, it removes this. So we have now this is there, the third one, this finishes earliest is this, so it will remove this one. So what is happening, this one should be removed, it is removed, and now we have this. So in fact, okay, I could not see that, okay, this is, they are not overlapping, so 5 jobs will be done. Okay, so this is the case, and this will give us the optimal solution. So why? Because this always, at every step, what is happening is you are having the maximum amount of time left in which you can schedule jobs. Okay, so initially R is the set of all requests, A is empty where you want to put the job that need to be scheduled. While R is not empty, choose I such that it finishes time of that is the least minimum or earliest one to finish. Add it to A, remove all from R request that overlap with I, return the set. So this is the simple algorithm. What we are doing, just every time you choose the job that is finishing the earliest from the available ones, then what you do, add it to the set of jobs that will be scheduled, and then you also have to remove all those jobs that overlap with it, and keep on doing while your set is not empty. Now we want to find what is the, so let's try to see, they are proving it, but we will not go into it, and we will try to find the time complexity. In fact, the proof of these greedy algorithm is much harder than your algorithm itself. Okay, so running time, let's try to see. So implementation and running time, choose such that finishing time is the least. So for that finishing time, we basically sort it based on the finishing time, so we can easily do that. Then what happens, so pre-sort all the requests based on their finishing time. It will take O of n log n time. Now choosing least finishing time is O of 1, so we sort it, and every time you will just find whichever is the least. And then let's try to see, keep track of the finishing time of the last request added to it, then check if starting time of I is. So now what we have to see is that we have to find all the overlapping ones. Non-overlapping checking, as we told, we just have to check the finishing time. They can overlap like this. Okay, so S1 F1 S2 F2, so you have to check how, if it is overlapping. So S2 should be less than F1 and F2 should be greater than F1, or if otherwise the case will be S3 F3, so then S3 should be less than S1 and F3 should be greater than S1. Then in both these cases it will overlap, so you need to check that. That can be done. And so what it becomes is that the checking of non-overlapping is O1, so it will be for total of maximum you have to check with n overlaps. So sorting required n log n, and then n was for overlapping checking, so which is O of n log n. So I hope you understand this, it's quite interesting. So the thing for greedy method is that choose some method that's looking intuitive to you, that okay, that will give you the best result. Then you become an adversary. Okay, that okay, no, I have to prove it to be wrong. You try out with certain examples that okay, this is wrong. If you find some that method is of course wrong, it's not going to give you optimal solution. But if you find something for which you are having difficulty in proving that it's wrong, that will be your solution, but you need to prove that, and proof is a bit difficult here. And then find the time complexity and all. So that's the case. I hope you understand this. Thanks a lot.